Welcome to my lecture. Today we are going to discuss about the section 1.5, which is solution of partial differential equation using Laplace transform. So we have two variable functions u, x, t, function of x and function of t. Then the Laplace transform of u, x, t, we denote it as u, x, s, which is general Laplace transform of t, time variable t with variable s. And then the Laplace transform of the partial derivative with respect to t, derivative of partial derivative with respect to t, that will be the general, like the general derivative. So you have s u x s minus u x 0. But in the case of partial derivative with respect to x, we need to use the definition. So 0 to infinity, partial derivative u with respect to x e to the power minus st dt. And then this integration and derivative will be exchangeable. So we take the partial derivative with respect to x outside, then it will be u xt e to the power minus st dt. And this one is the Laplace of u x t. Okay, so this is Laplace of u x t. Okay, so whenever you take the Laplace of u x, then this will become a function of u x s. So in that case, we can take the ordinary derivative instead of the partial derivative. So we can write it as d dx u x s. Now we have here one initial value problem of partial derivative. So it is that we have to solve it x partial derivative with respect to t of u and partial derivative with respect to x of u is equal xt with the condition u x0 is equal 0 and u0 t is equal t. So let's have the Laplace transform on both sides, and you will get it. This one x is treated as constant, and then Laplace transform of this one, and plus L. Here is the partial derivative of Laplace transform with respect to Laplace transform of the partial derivative with respect to x, and it's x LT. So here we already know the formula, and this one is this, and this is the derivative of u with respect to x, and here is x s square. Then we see that this has become an ordinary differential equation d dx u x s plus x s u x over x s square. We need to solve this first order differential equation, non-homogeneous differential equation, and we need to do it with respect to the integrating factor. So now what is integrating factor for this is calculate as e to the power this term dx. So here sx dx, so which will be s x square over. Okay, so then we multiply on both sides. So the solution will be e to the power s x square over 2 u x s equal the x over means the non-homogeneous part x over s square, and the multiply the integrating factor with respect to dx plus as. As is the integrating constant. Since here is s is a function which is constant here, so we have to take as instead of constant number function of s. And then we solve this integration by the substitute method. So you know this method. We'll substitute here s x square over 2 equal tau. So this integration will become s x dx is equal d tau. So we have here x. We will multiply with s. So then you will get it here. 1 over s to the power 3, and then it will become a to the power tau d tau. So solving this, it will be e to the power tau s to the power 3. We are not putting this limit. So e to the power tau s to the power 3. So it will be e to the power x s square over 2 over s to the power 3. So this the integration is here. So now we are not putting this constant here for this integration because we use this constant here. So we just substitute it here, these values, this integrations, and we will simplify it further. So we substitute here, these integrations will reduce to in this form, okay, as. Now we have to calculate it. This means values is here. So we need to use this conditions u0 t is equal to t. Okay. So how will calculate it? If you put x equals 0, everything is coming to the s. So therefore we cannot put it here t. So what we will do? We need to get the this. We need to convert this to u0s. For that, what you have to do? We have to take the Laplace transform on both sides. So we'll take the Laplace transform. So it will become u0 is equal to 1 over s square. So therefore, we put it now x is equal to 0. So we'll get from this equation that e to the power 0 u0 is from this equation e to the power 0 u0 is, and e to the power 0 over s to the power 3 plus as. So this one is 1 over s square, and this is 1 over s to the power 3 plus as. So this will give you as equal to 1 over s square minus 1 over s to the power 3. And then finally you got the constant as is here. So we substitute it form, and after simplification you have this form. And taking the inverse of this, you will get this. So here is unit step functions of x square over 2, and then you can get it. This is 1 over s square is t. So therefore t minus x square over 2 unit step function x square over 2. Here is t t and there we go. So this is the final answer of this.